All right, so we're in systems of linear inequalities. Very similar to systems of equations. We can still use all the same methods. So we can, our main use is going to be graphing to solve these. We can also use elimination. We can go play assassin, or we can do substitution. And do what my wife did in school with our identical twin. So we can use all three of these together. Now the key is finding those points of intersection so that we know the exact points. It's going to become big when we do the word problems part of this. So let's go ahead and solve that system. We'll do it by graphing. The thing here is that you have to be really neat and clean if you're going to graph these to solve them. So use graph paper. There's no substitute for no substitute for graph paper. Okay. Well, yeah, I guess there is a substitute for graph paper, the graph stamp. But you're not as cool if you use the stamp. Alright, anybody? Where is y greater than equal to 0? Which line is that? Yes, okay. And then it's equal, so I leave it solid, right? And then I shade above it. And it's greater than. Does anybody want colors? I got colors if you want to. Alright, suit yourself. Change the color in math class. Okay, x greater than equal to 0. And then if you need to, when I do these, I think in slope intercept form you can rewrite it. It's okay. 1, 2, 3, 4, 5. What's the x-intercept? 5. As I plug 0 in for y and solve. A solid line here and shade. So where is our solution set? Right here. That's where all three shading. If all three are shading this triangle, correct? That's what we solve. That's our solution set. Anything in there works. Okay? So I'm going to go ahead and editing. Oops. Yep. Figure that out. There's some new vocab words here our book uses that you're gonna have to know. Okay, this is called a polygon region. A polygon, right? That's a triangle. Could be a square, it could be a rectangle, it could be a pentagon, it could be a hexagon. We're not going to subject you to much more than that. An octagon, polygon, etc. So it's a polygonal region. It has vertices. Can you tell me what those vertices are? Yeah, that's the corners. And those ones were easy, right? Sometimes they're not so easy, and you have to use elimination or substitution to find them. Right? It's not that boring, I think. You're going to have to use that, and you're going to have to think when we get to the word problems. So you have to be able to make that shape and find these points of intersection exactly. All right? You want me to show you one of the algebra methods to find those, or are you okay with that? Okay, so if I want to find this point here, that involves this line, right? And it involves this line. So we need to solve that system. X is 0. So I'm going to plug it in here. So you have y. So y is basically 5. So we have the point 0, 5. So I use substitution, right? I put 0 in and solve. Okay. Anything else there? We're good. Basically a system with shading. Not much more to it than that. Okay, let's see. Yeah. Do you want me to show you a word problem? Yeah. Yeah. I don't want to, but I will. So sometimes you want to be lazy, and you shouldn't. Yeah, that's me. All right, in shipping, this is straight out of your book. You know when you go to the post office, they measure all the edges of the package you send off? Okay. In this problem, so length and girth cannot exceed 84 inches. You know what girth is? No. How far around? Okay, so this would basically be the perimeter of the base. So they're counting all 3 dimensions there, length, width, and height. They're just putting it in a 2-dimensional context so we can solve it on a 2-dimensional coordinate. So girth is distance around or perimeter. Okay. A package requiring special handling is one which the length is greater than 60 inches. Okay, so special handling, length above So they would charge extra for either of these. Okay, so there are extra charges here. I went to the UPS store a couple weeks ago. It was a big box. Had bike wheels in it. I had sold on eBay. And it's like 3 or 4 pounds. And there's almost nothing in this box, but they wanted like $40 because it was really big. Okay. So there were extra charges involved there because it was big. The question is, what size packages qualify for both criteria? That means you paid more, like doubling or double the cost. Yeah, so you got a box that's at least 60 inches long and one that is bigger than 84 inches around, which is a lot. It's literally about this much. Plus this tall. So it's big. Okay, what are our equations? You all right, guys? Let's take a step back. What are our variables? No, you tell me. Yeah, length and girth. What are we going to call them? L, length, G, girth. Nice. So define your equation variables. Now write your equations. What's this one? I'll even write it in red. If I said you had $20 and you had $40, how much money do you have? 60. I can do that. I added. So I'm going to take L plus G. The trick here is to get the sign right. Look at the question's asking. We want to be above it. Right? We're asking which boxes qualify for the higher cost. So cannot exceed means it has to be less than or equal to be under it, or greater than to be above it. So these words play big. These words. Okay, and then what about this one? Yep, ranked above 60. And that's strictly greater because it's above 60. They don't include 60. All right, let's talk about it. Let's call this one our length. And this one our girth, just for labeling's sake. You can do it the other way, you get the same answers. I just chose L is 60. So if I need to go to 60 up here, 10, 20, 30, 40. Okay, so I got all the way to 100 because I like where the next sense. My blue line
Is that dashed or solid? Dashed, because it's no equal sign. Shaded above. Keep it up, or am I going too fast? Alright, and this one, I'll rewrite it again. That's 90, I'm going by 10s. 84. And then the x-intercept, what is it going to be? What makes this 0? 84. Yeah. And then, I know there's a straight line tool in here somewhere, but I'm just going to go with that. And then shade above it then. So where's our solution set? What? Double shade area, yeah, that'll be in here. Anything that satisfies a point in there. Just began pick on M&A about 30 minutes ago. Can you tell me a point in that shaded area? Yeah. Now, what does that mean? Here's where it gets fun. In the context of the problem. Anybody fill us in on that bit of information that you're going to get asked on your test? What does that mean in the context of the problem? Yeah. Okay, so how big is this package? Yeah, that's our package size. And it qualifies for both oversized criteria, right? Does a package of that size qualify? Why not? Yeah, the dash line. Anything on the lines does not qualify. So that one would be 60 of the x, right? And what's the y? Negative 60 plus 84. Right? So if you want to push it, there you go. You want to find a process size. Yeah. Any questions on that one? Think you can handle some of these? Okay. Just point out, important to be able to write these equations, because in 2 days we're going to be doing this. It's called optimization. I'm going to give you a word problem, and you're going to maximize profit or minimize costs for businesses. Okay? You're going to be doing efficiency calculations using this math. Right? But all you're given is a word paragraph. You have to write the equations, graph it, find the vertices, tell me the most optimal points of profit or least cost, etc. Okay? That's in 2 days. Let me get you your work. You got about 10 minutes to get started on it. Where'd my pointer go? Alright, so it's 2.6, 11 through 14, 17, 18, 27, 30 to 33. We'll talk about it tomorrow at the beginning of class.